Down to our last problem, sample number 4 for module 3. The velocity versus time graph of a car while traveling along a road is shown. So this is the velocity versus time graph of a car. Determine the acceleration at 2.5 seconds, 10 seconds, and at 25 seconds na time. Also, if the position is 0 when time is equal to 0, find the position when time is equal to 5 seconds, time is equal to 20 seconds, and then time is equal to 30 seconds. So, atong sa may buhaton na to ani. The VT of a car while driving. Determine the acceleration. So, we were asked the acceleration, and we were also asked the position as. So, diba, to get the acceleration, we know that the acceleration is equal to the derivative of the velocity with respect to time. Pero kani siya, this is applicable if nate equation ani nga line, this line, and this line. So kabalo na tani iyang equation is just 20, but this is an inclined line. Actually, we can use basic algebra to get the equation of these lines. So but remember that we have another way to measure the acceleration, right? Natoy acceleration is just equal to the change of velocity with respect to time. This is from our first topic. Did you remember? This is the average velocity equals to the change of velocity with respect to time. But kani siya, magamit lang ni siya nga formula if the velocity is linear. Yung relationship is linear. So kung yung graph is line, then equation ni is naka-line. So direct relationship siya. But if naka-curve na iyang graph like this or that, so this is not applicable. We need to use the differential. So since mo naman din yung acceleration, so I will draw first the velocity versus time graph. This time in seconds, this velocity in meters per seconds. So natay 5, 20, and 30 seconds. So this is 5. Let's see, this is 5 seconds. This is 20 seconds, and this is 30 seconds. So isa ra ka velocity is 20 meters. So from 0 to 5 seconds, 20 no velocity. Then constant siya until 20 seconds, and then hinay siya until 0. So connecting the points, we got this koan. Okay. So sa acceleration, para makuha na to si acceleration. So determine the acceleration when t is equal to 2.5, 10, and 25. So pili acceleration at 2.5. So this is 5, this is 20, and this is 30. So ato lang butangan og acceleration 1, acceleration 2 para mas dali na to makuha. So acceleration 1 is equal to the velocity at 2.5 seconds. So 2.5 seconds, diba? So first na to is interval is from 0 to 2.5 seconds. So 2.5 minus 0. Unsa man atributang nga velocity? So if at 5 seconds ang velocity is 20, at 2.5 seconds, since this is linear relationship, it means at 2.5 seconds ato pong velocity is just 10. So 10 minus 0. This is equal to 10 over 2.5. So our acceleration at 2.5 seconds is just equal to 4 meters per second squared. How about at sa nisunod? 10 seconds. So kung inyong tan-awon, ang 10 seconds is between the interval 5 to 20. So 20 minus 5, this is 15 seconds. So ang 10 seconds is naa diri somewhere. So klaro kay sa graph, okay? So A2 na to is just equal to velocity So let's say a time interval from let's say from 5 seconds to 10 seconds. So 5 to 10 seconds. So ang V2 minus V1 over T2 minus T1. Velocity 2 na to at 10 seconds, that is 20. And then velocity at 5 seconds is also 20. Over time at kadua gani is 10 seconds minus 5. This is 0 over 5. Or acceleration na to at 10 seconds is 0. And acceleration 3 na to at time interval. So ingon niya diri at 25 seconds. So let's say from 20 to 25 this point. So time is from 20 seconds to 25. So acceleration 3 is equal to, so mo to siya no, ang velocity at 25 seconds here. So kung makita, this is a line, mura rin siya triangle. So direct relationship. So from 30 to 20 to 30, that is 10 seconds. Height is 20 seconds. Therefore at 20 to 25, that is 5 seconds. So ang iyang velocity at this point sa 25, that is 10. So final 25, 10 minus velocity at 20 seconds, that is 20, over time of final 25 minus 20 is just equal to negative 10 over 25 minus 20, that is 5, equals to negative 2 meters per second squared. So mo ito acceleration at this one. So sa may other way nga pag-solve na to ani para mas dali siya na to makuha. So ito position. Okay, so di ba ang acceleration from this point to this point of the line is constant, di ba? If you remember, if you graph this one, yung acceleration ani uporma siya og line or 0 degree nga line. It means that is constant. So from this point to this point that is constant, then we can just safely assume atong pag-solve sa acceleration is just equal to 20 minus 0 over, wala lagi po gikanta diri, so 5 minus 0, that is equal to 20 over 5, that is still 4 meters per second squared. Sa ato ang 2, we can just safely assume yung atong solve pagkuha na to sa acceleration is from this point 20 seconds to 5 seconds para makuha na to si 10 seconds ng acceleration. They are all the same. So at 25 iyang velocity is 20 minus at 5 seconds iyang velocity is 20, then ang time is 20 minus 5, so this is still 0. And at 3, instead nga ito itong giputol-putol, ang velocity ani at 30 seconds yung final, that is 0, minus velocity ani sa 220, that is 20, over 30 seconds minus 20 seconds, that is negative 20 over 10, still negative 2. Okay, so now we are asked to find the position when t is equal to 5 seconds, 20 seconds, and 30 seconds. Okay, so I'm gonna make a graph. Same time versus velocity. Position versus velocity. Position in meters. So, diba, ito naman ito na istoryahan before. Now, we just take the area. So, since this is a first degree line, we can assume that yung itsura ani sa position ng graph is like this, second degree. So, this is our area 1. This is positive area 1. This is our area 2, still positive. And our area 3, still positive. So, from position na to is, this is our position para aning function. Since this is a 0 degree line, ato ang ma-expect is this is an incline or first degree line. So, kung positive man siya, sa ato panisaka siya. Then kay positive man ni siya, and then we know the direction of the curve for the second degree is paana. And since positive man siya, i-mirror na tong curve, mabali siya, paana yung itsura. Then, we can assume that itsura niya there is something paani. So this is our position versus time graph. But still don't know yet the values of this point. So I would like to name this S1, S2, and then S3. So para ma-solve na to sa S1, S1 is just equal to area 1. So area 1, this is triangle. 1/2 base. So ang base niya is from 0 to 5, that is 5 seconds. Times the height, which is 20. So 5 times 20, that is 100 divided by 2. S1, we have 50 meters at this point. So this is 50. How about from this, how about this point? So S2, ang S2 is equal to S1, this one, plus kani siya nga height. We call this delta S2 plus delta S2. Ang delta S2 is just area nga kani, area 2. So naatay 50 plus ang area 2 na to, length times width. So 20 minus 5, that is 15 times 20. 15 times 20. So ato ang position at 20 seconds is just equal to 350 meters. Then atong S3 is just kani diba? S2 plus kani delta S3. So S2 plus delta S3. So we know that ang delta S3 is just equal to area 3. So S2 is equal to 350 plus triangle naman po niya siya. 1/2 base times height na 20. 10 times 20, that is 200 divided by 2, 100 plus 350. S3 is equal to 450, position 3. So this is our answer.